Hello everyone, welcome to my lightning talk about do-it-yourself security and privacy and how you can set up your very own VPN in 10 minutes. Unfortunately, I have to start with admitting that the title of this talk is a little bit of a lie. I plan to spend at least 5 full minutes motivating why anyone would care about personal VPNs. So the actual rolling part of this presentation will have to happen in far less than 10 minutes. So with now no time to waste, let's get started. I suppose many of us has developed a much closer relationship with VPN technology during the recent crisis than we ever thought. During the COVID crisis, remote working has become the new normal, and a key technological enabler for that has been VPNs. VPNs makes it possible for employees to access corporate networks securely from the comfort of their own home. Corporate VPN systems are often expensive, proprietary, and complicated to set up. Typically, one also has to use hardware dongles to log in. So the topic of this talk will not be that kind of systems. Instead, I will talk about how one can employ VPN technology on a more personal scale. But why would one do that? I could actually think about at least 2 scenarios where personal VPNs fits well. First, for increased security and privacy for general browsing needs. For instance, when you are using a public Wi-Fi hotspot, you will always run the risk that the operator of the access point will try to snoop on your traffic, perhaps even rewriting it. Today, most of your traffic will be secure and encrypted, but there remains classes of traffic which is transmitted in plain text. For instance, the host names you are browsing to. Adding a VPN provides a secure tunnel through less secure points on the internet. Second scenario for personal VPNs. If you are a tinkerer and have a lot of projects running at home, for instance, Raspberry Pi servers, NAS storage units, IP cameras, sensors, and so on, it can be convenient to access those even when you are not at home and have access to your home network. Then you can hook up your home network to a VPN server running in the cloud and connect to this VPN service, for instance, from a mobile phone when you are not at home. This brings me to VPN services. There is no shortage of commercial offerings online, some more shady than some. But rather than putting all your faith to a commercial VPN providers and also some of your money, there's a far more attractive option. You can go the do-it-yourself route and set up your own VPN on your own service. To accomplish that, we will use Wireguard today. Wireguard is a modern piece of VPN software, open source, which is actually part of a Linux kernel. Wireguard is also available for all popular platforms. You can run Wireguard VPN clients on Mac OS, iOS, Android, Windows, and so on. Wireguard is also surprisingly easy to set up and understand. The configuration of Wireguard is based on public-private key pairs, a bit like when you access Git repos on GitHub. You generate key pairs for all the pairs in your VPN, and then you exchange the public key of each pair with the other party so that they can authenticate each other at a later point. So let's get started. Here I start a Linux server on DigitalOcean, selecting the latest Ubuntu version, starting it up in London. So then we log in and refresh the list of available packages so that we can install the Wireguard command. With the Wireguard command in place, we can generate keys. So we start with generating a private key. and we will let this private key be the private key for our VPN server. And based on that private key, we can generate a corresponding public key. Then we have a complete key pair for our server. Then, as I mentioned before, we need another key pair for the client. So we follow the same procedure, generating first a private key and then a public key. So with these keys available, we can proceed with configuring the Wireguard VPN server, starting with a configuration file. So here, first define the IP address of our VPN server. We use a .10 address, and we associate this pair with a private key, which we have generated previously. And this allows for the client, when it connects later, to be sure that he actually talks with my server and no one else's Wireguard instance. We define on what UDP port Wireguard will listen. And then the server needs to know that the client will be its peer, that the client will connect. And the server, of course, also needs to be able to verify that it's the expected client which connects. Allowed IPs specify that the client will connect from a .11 address. With the server configuration in place, we can bring up Wireguard interface on the server. Now Wireguard is actually running, but there is no peer yet which has connected. We proceed with configuring Linux. Here is quite technical commands, but what it does is basically enabling Linux to send traffic it receives from a client through the VPN, send that traffic out on the public internet. With these technicalities in place, we can proceed with configuring the client. The client configuration is very similar to the server configuration. We define the address for server. For the client, we use a .11 address, associate that with a private key, the same dance as before, so the server can authenticate us when we connect. Some DNS configuration. And then we must, of course, tell the client about the server. That the server will use a key corresponding to this public key. And also we, of course, need the public IP address of the server. And finally, we use this allowed IPs configuration statement to tell the client that he should send all his traffic into the VPN tunnel. So with this in place, we have a lot of configuration we need to get to our mobile client, and we don't want to enter that manually. Instead, we use the convenient QR encode software, generating a QR code for all this configuration. And then we could start up the Wireguard client previously installed on this phone and simply scan this QR code from the terminal, importing all this configuration. We simply need to provide a name for the tunnel, and we can save it and enable the tunnel. And now we can go, for instance, to a web browser, go to what is my IP address and verify that, yes, indeed, we are using the VPN and we are connecting using DigitalOcean in London. So that was all. I encourage people to look more at Wireguard if you're interested. It's a lot of good material available online. Thank you.